Hi students, let us analyze this next exercise. They say here that a roller coaster car goes the top of a circular loop-the-loop at twice the critical speed. So what is the ratio of the normal force to the gravitational force? So we want to find in this case the ratio of the normal force to the gravitational force. This is our unknown in this problem. Now, what do we know here? That in this case, when the roller coaster car crosses the top of a circular loop, its velocity or its speed is twice the critical speed. So the speed at this point here is two times the critical speed. Now, what do we know from the lecture? We know that the critical speed will be equal to the square of the radius times the gravity. So this would be 2 times the square root of rg, because the critical speed, for a system like this, for a roller coaster, at the top of the trajectory would be r over g. So for a speed lower than this one, the car is going to fall, and it's not going to make the loop, right? So which are the forces we have acting here? We have the normal force pointing downward, all right, that is the reaction of the track of the roller coaster on the car. We have the force of gravity acting on the car, right? So we have these two forces, and then due to these two forces, we will have a net force pointing downward here. So we can now apply Newton's second law, right? And we can say that the net force, which is the sum of the forces we have in the direction of the y-axis, is equal to the mass times the centripetal acceleration, right? Would be equal to mass times centripetal acceleration, because there would be, of course, here as the resonant force, and we have a body that is going in circular motion, we will have a centripetal acceleration here. So what we need to do next, which are the forces that we have in these sort of forces? Well, we will have the normal force plus the force of gravity equals mass times centripetal acceleration. We're gonna now solve for the normal force, right? And we can say that the normal force is equal to mass times centripetal acceleration minus the force of gravity. Now, what is this centripetal acceleration? Is b squared over r. So we substitute now. We say mass times, this is b squared over r minus this is force of gravity, is mass times gravity, right? So now we know that this b is twice the critical velocity, so it's 2 times the square root of rg. So we have that n is equal mass times, then we have 2 square root of rg square over the radius minus mass gravity. So this would be mass times 2 square would be 4 square root of rg square would be rg over r minus mass gravity, right? And then now we can just basically cancel. We reorganize now the factors here. We get 4 mass rg divided by r minus mass gravity. We can cancel the r out. We get this is 4mg minus mg. 4mg minus mg, of course, would be 3mg. So the normal is 3 mass gravity. This is the value of the normal. We know that the force of gravity is just mass gravity, right? So if we want to find the ratio, okay, between the normal to the gravitational force, in this case, just just in terms of the magnitude, where we have my normal 3 mass gravity over my force of gravity, which is mass gravity. We cancel this out, so we have that this ratio is equal to 3. So the number 4 will be 3 times the value of the gravitational force in this problem. So that's it. That is the solution of the problem. So we found the ratio of the normal force to the gravitational force. Super important here to remember that as part of the problem, was given that the speed of the car while crossing the top of the circular loop-the-loop was twice the critical velocity, so it was 2 times the square root of rg. I hope the exercise was interesting for you, and I invite you to subscribe to my channel.